Okay, this is the first lesson in Outcome 3. We've made an entry into the unit on evolution. Our first lesson is feathered or leathered? What can we learn from fossil evidence? You should have some guided notes for this lesson, so go ahead and take those out. Get ready with a pencil. If you missed it in class, we had a slide up that looks like this. This is a fossil of something. And we closely examined it and noticed that there are long arms, right? We have some legs with some talons or some claws, and several students pointed out that you can, if you look closely, you can see some feathers here. You can also see that on the tail as well. This organism had a very long tail. And so from this picture, we talked about what can we conclude about where it lived? What did it eat? How did it move? And what else can we conclude about this? Now it's important to note that this fossil is of an organism that's roughly the size of a raven, right? A small bird, maybe a medium-sized bird, and that really helps to inform our thinking about this. But we talked about how the claws might indicate, well, first of all, that it could grasp onto things, and the wings might show that it might be evidence that it was able to fly. And if we were to take a closer look at the teeth, perhaps we would be able to see if it has sharp teeth or no teeth at all, or just a beak, and that might add to our knowledge of what it ate. A lot of students were comparing what we know about birds today to this fossil. So what do birds eat today? Well, berries and maybe small insects. So we can conclude some different things from that. So this is actually a fossil of an organism called the Archaeopteryx. And now this is a significant fossil because it is considered to be the missing link, or one missing link between what we consider to be dinosaurs, so a group of dinosaurs called theropods, and modern day birds. So if we were to examine 3 different fossils here, we could see that the theropods, right, like this one at the top, are walking on 2 legs. They have relatively short arms, kind of your traditional Tyrannosaurus rex type fossil. And this is a group of dinosaurs called the theropods. We looked at these fossils and we said, well, there's a long tail, and they have reversed first toes. We marked on the slides what are some similarities between these 3 and what are some differences. And we could see that the tail is present in all 3, but this one looks to be a lot thicker. If you were to put some muscle and tendons around that, this one would be a lot thinner, a long bony tail, maybe even a little bit lighter. And by the time we get to this fossil of a chicken, that tail is almost nearly gone. Okay. All 3 of them have reversed first toes. Okay, this would be helpful to grasp things. And another difference is that we start off with very sharp teeth in the theropods, and these kind of change into reptilian teeth. Okay, so maybe fewer teeth and no teeth in the chicken. Okay, so there are some similarities, but you can also see some differences coming about as we move through these fossils. Okay. Now, we consider that the theropods are older organisms, and over time they changed. Okay, so some of their features changed or evolved to allow them to eventually become flying organisms. Okay, as they evolved, they lost bone density, which is one thing. It would have allowed something like the Archaeopteryx to be lighter right? A lighter weight, and that would allow them to maybe fly short distances. The chickens are not the greatest of flying organisms right now, but they have lighter bones, and some modern day birds, many modern day birds actually do fly. So the point we wanted to make with this one was that this is a great example of what happened through evolution. So the theropods were likely the dinosaur ancestor of today's modern birds. So the Archaeopteryx then was this transitional fossil, so kind of a halfway point between dinosaurs and birds. And the theropods did not fly. They were too heavy. They were just not built to fly. The Archaeopteryx is thought to have been able to fly short distances, and then modern day birds with some of their evolved features are able to fly. We read a passage in our workbook. This was on page 1. I would encourage you to pause this right now and go through and read this. Just a few paragraphs about some feathers that archaeologists or paleontologists were able to examine from fossils. Okay. Hopefully now that you've read it, you would have heard about the word melanosome. Okay, now these melanosomes are an organelle. It's kind of like a nucleus or a mitochondria, one of those little things that is inside of a cell. Now, the significance of this, why this is so interesting, was that these scientists found that the shape of the melanosome, okay, indicated whether a part of that feather was black or red. So the sausage-shaped melanosomes, if these were found in the fossils, that meant that that area was black. Okay, now if the melanosome was round like this would give off a reddish color. We were able to deduce this because we know that our red-tailed hawks that we have today in our world, they have melanosomes that look like this. They're spherical. So we are able to translate that and look back at our old fossils and say, oh, well, this dinosaur had red feathers or red coloration in their feathers. And this one over here had black feathers because they have sausage-shaped melanosomes. And maybe you can even tell whether something was striped or polka dotted, and maybe we could even find different colors. Maybe peacocks would be able to give us some light on what kind of melanosomes might give off a blue or purple hue. That'd be pretty cool. So that is the so what part of it, right? That gives us some indication of what color these dinosaurs might have been. And these melanosomes, okay, are fossil evidence, and they're not necessarily just present in feathers. We can find them in zebra fur, and maybe other forms of skin or things on the outside of the body. So that's pretty cool. In your workbook is also this very complicated looking, let's see if I can move myself over here. All right, there is what we call a cladogram. Okay, this is a little bit of a complicated graph, but I would like you to look over it. We have our timeline up here. So this side over here is ancient times, and as we move towards the purple, we're moving closer and closer to current day. Okay, so we will talk more about cladograms. This is a cladogram, a type of graph that allows us to show how different organisms kind of split off and became different things over time, and which features entered into the picture along the way. So if you look at this here, you have something like a Triceratops, right? This one was around from roughly 230 million years ago until, I don't know, however many, let's see, until roughly this time. Okay, not super important. They had 5 digits on their hands or paws or feet or whatever. Okay, now as time went on, they divided up, or different organisms may have gone into different environments, and you have some organism like the Eoraptor, or these coelophysoids, and any organism coming up after this point would have had 4 digits in their hands. Okay, this is one change that happened between these guys and everyone else. Okay, as these continued to move into different environments and change and adapt to their environments, their bones also became a little more hollow. Not overnight. It wasn't that all of a sudden none of them had, dense bones anymore. This changed over time, very slowly, but that progressed and progressed. And we have other things like the pubic boot, or 3 digits in hand, coming into play right here. So everything after this had a pubic boot and 3 digits in their hands. Hollow cylindrical feathers came into play here. So everything after that had hollow cylindrical feathers, tufted feathers, feathers with barbules and hooks, okay, or maybe they made nests. Asymmetrical feathers, long arms. I can't even see this top one. But eventually all of those changes led to the development of what we know to be the living birds today. And the living birds came from an ancestor with 5 digits and very dense bones, and now these birds have 3 digits in their hands and very hollow bones and feathers and all of the other characteristics that you see here. So that's basically the idea of a cladogram, and how it can show us how different traits changed over time, and how an organism like the Ornithischian dinosaurs were able to change and evolve into something like our living birds today.